Just days ago, a comet near the Sun erupted, its brightness leaping overnight, its tail fanning out wider than 5 full moons. Then, the Sun unleashed its mightiest flare in months, blasting a massive wave straight toward the spot in space where that comet, R2 Swan, is now heading. On October 21st, Swan will glide closer than ever to Earth, just as another interstellar object passes in near-perfect alignment. With solar storms set to slam into the comet's giant tail, no one knows what's about to unfold. Will the sky light up with drama, or will the comet vanish into silence? The chain reaction has begun. So, what happens when a cosmic visitor meets starfire? September 12, 2025, Comet C 2025, now simply called Swan, rounds the Sun at a distance of just half an astronomical unit, closer than Mars ever comes to Earth. At first, the numbers seem routine. It's a faint, slow riser, with its magnitude hovering around 7.4 and its tail stretching a modest 2 degrees across the night. But comets are built for surprise. Just 2 weeks after its closest approach to the Sun, the glow jumps. On September 26th, amateur astronomers in Japan and Australia catch the first signs, a sudden leap of nearly a full magnitude, pushing Swan into naked-eye territory for anyone under dark skies. By the end of the day, international forums are buzzing with live photometry, confirming a brightness surge to 5.7, which then holds near 5.8 through September 28th. This isn't just a statistical blip. Outbursts like this point straight to the nucleus, a frozen core battered by centuries in deep space, now being hammered by solar heat. As the comet swings out from its closest pass, volatile pockets buried beneath the crust reach a breaking point. Gases burst through, carrying dust and ice with them, swelling the coma and feeding the tail. The effect is immediate. Light curves deviate from prediction, and every fresh observation becomes a clue to what's happening below the surface. Thermal stress, venting, even local collapse, all are on the table. Some observers even spot hints of jet-like features near the nucleus, possible evidence of fractures in the crust or new vents opening up. The comet's behavior is diverging from the standard playbook, drawing the attention of both professionals and a global network of backyard astronomers. For now, the numbers are clear. Swan has entered a new phase. Its inner engine is exposed, and its next moves are unpredictable. The question isn't just how bright it will get, but what this unleashed energy will do to the comet chest structure and to the vast tail now unfurling behind it. And what a tail it is! Stretching more than 2.5 degrees across the sky, that's like laying 5 full moons end to end. For skywatchers, that scale changes everything. This isn't just a fuzzy dot lost among the stars. It's a structure you can trace with binoculars, a streak that demands attention even in suburban skies. The sheer span means more of the comet's secrets are on display. Knots of dust, shifting rays, and the faint electric blue of the ion tail, all shaped by the solar wind. The tail's architecture tells a story in real time. Dust, which is heavier and slower, lingers close to the comet's path, forming a broad, sunlit fan. But the ion tail, lighter and more volatile, can snap, ripple, or even break away under the right solar conditions. With Swan's tail now covering a chunk of sky wider than any city skyline, even small telescopes can pick out its structure streamers, kinks, and sudden bends. For observers tracking it night after night, the changes aren't subtle. A single evening can reveal a new twist, a fading plume, or a sudden brightening as fresh material streams out from the nucleus. The global comet community is already responding. Amateurs across continents are stacking exposures, comparing notes, and sharing time-lapse sequences that reveal tail motion hour by hour. Forums are lighting up with reports of subtle color changes: icy blue for ions, golden for dust, hinting at the complex chemistry at work. The comet's position, low in the southern sky for much of September and October, favors observers in Australia, South Africa, and Argentina. But even northern latitudes get a shot as Swan climbs higher and the moon wanes. For anyone with even a modest pair of binoculars, the next few weeks offer a front-row seat to a live experiment in solar system physics. The tail's reach means more than just a spectacle. It sets the stage for what happens when the Sun sends its own shockwave into the same quadrant of space. The question becomes not just how long the tail will grow, but how it will react when the solar storm arrives. That storm began on September 28th at 8:43 Coordinated Universal Time. The Sun erupted with an M6.4 class flare, its strongest in months. For most of September, solar activity had been unremarkable, with X-ray flux readings from the GOES satellites trending flat, hinting at a lull in the current cycle. Then, without warning, the X-ray monitors spiked. The flare's energy output, measured in the millions of kilowatts, lit up the GOES 16 and GOES 18 charts in near real time. Solar physicists at NOAA's Space Weather Prediction Center scrambled to assess the event, cross-checking with data from the Solar Dynamics Observatory and the SOHO coronagraph. This was not just another solar hiccup. MCOS flares are mid-tier on the scale, but an M6.4 is enough to catch the attention of satellite operators and space weather forecasters. The flare's origin, active region 4232, a complex sunspot group with a twisted magnetic field, placed it in the same quadrant of the Sun that Swan was now approaching. Within 30 minutes, coronagraphs confirmed the launch of a coronal mass ejection, or CME. The CME's initial speed, estimated between 800 and 1,000 kilometers per second, puts it among the faster eruptions of the year. Inside operations rooms, alerts rippled out. Satellite teams double-checked their protocols for radiation spikes, but this CME was not Earth-directed. Instead, the focus shifted to what lay in its path. The timing, just 2 days after Swan's outburst, drew immediate notice. Duty officers flagged the event for Comet scientists, who began modeling the possible intersection of the CME with Swan's expanding ion tail. For now, the numbers tell the story: an M6.4 flare, a CME racing outward, and a comet with a massive tail right in the line of fire. The Sun, quiet for weeks, has sent a powerful pulse into the same sector of space where Swan is putting on its own show. The intersection of these events is rare, and every instrument, from X-ray detectors to ground-based telescopes, now has a reason to watch closely. Inside the NOAA Space Weather Prediction Center, the race began as soon as the flare peaked. Analysts pulled up real-time feeds from SOHO's LASCO coronagraph and Stereo A's heliospheric imagers, combing through frames for the expanding arc of plasma. The CME, launched just after 8:45 UTC, fanned outward with an initial speed near 900 kilometers per second, fast enough to cross the average Earth-Sun distance in less than 2 days. Its angular width, measured at approximately 90 degrees, placed it among the broader ejections of the year. But the crucial detail was its aim. This time, the blast missed Earth by a wide margin. Instead, model overlays showed the main lobe sweeping into the sector of space now occupied by Comet Swan. For the forecasting teams, the challenge was geometry. Solar ejections don't travel in perfect straight lines. They expand, twist, and sometimes fragment as they plow through the solar wind. To chart the CME's path, scientists stitched together coronagraph images, plotting the leading edge against the known positions of planets, spacecraft, and, for the first time in years, a comet with a tail longer than 2 degrees. Swan's coordinates, just inside Earth's orbit and slightly south of the ecliptic, put it near the predicted corridor, but the three-dimensional uncertainty remained. Without a direct Earth hit, inside plasma data would be limited, leaving ground-based and orbital imaging as the best tools for tracking the encounter. Every major forecast center flagged the event for Comet researchers. The question was, would the CME's broad front actually intersect Swan's tail, or would it sweep harmlessly past? The best estimates placed the CME's arrival in the comet's vicinity between 48 and 72 hours after launch, depending on the true trajectory and speed. Have you ever seen a comet's tail just break off? It's one of the most dramatic events in our solar system, and it might be about to happen right before our eyes. This isn't science fiction. This is real-time astrophysics, and you could be a part of it. Recently, our Sun unleashed a huge cloud of solar plasma, a coronal mass ejection, or CME. Now, this cosmic storm is hurtling through space, and its destination is a collision course with a comet known as Swan. Now, for us here on Earth, there's no need to worry. The CME is projected to be a moderate event, not strong enough to cause any effects on our planet. But for Comet Swan, it's a completely different story. This incoming wave of solar plasma could trigger a spectacular celestial show. We're talking about the comet's long, beautiful tail kinking, twisting, or even disconnecting entirely. So how does this happen? It's all about magnetism. A comet's ion tail, the one that glows with a bluish light, is made of charged particles or ions. These ions are stripped from the comet's nucleus by the solar wind, and then get trapped, clinging to magnetic field lines that stretch millions of kilometers behind the comet, like an invisible cosmic leash. The CME is also carrying its own tangled web of magnetic fields. The real drama starts when the magnetic field from the CME meets the magnetic field of the comet's tail. If the fields are oriented in opposite directions, what scientists call a southward BZ component, things get explosive. This is a phenomenon called magnetic reconnection. Think of it like a cosmic short circuit. The opposing magnetic field lines collide, snap, and then violently rejoin in a new configuration. This process releases a massive burst of energy and can literally slice off a whole section of the comet's plasma tail. The result? The comet's tail appears to break away, sending a glowing fragment drifting off into the void, and it happens fast. A new tail can start to form almost immediately after the old one is severed. The entire event can unfold in just a few hours. Sometimes the tail just develops dramatic kinks or sudden changes in brightness. It all depends on the exact orientation of the CME's magnetic field. What makes this event so special is that it's happening right where we can see it. Comet Swan's ion tail is enormous, stretching over 2.5 degrees across the sky. That's 5 times the width of the full moon. This massive exposed tail is about to feel the full force of the solar storm. If the CME makes a direct hit with the right magnetic alignment, the ion tail could snap away in as little as 90 minutes. For most comets, these events happen quietly, deep in space, unseen by human eyes. But this time, it's playing out on a stage visible through backyard telescopes. This is an incredible opportunity for scientists. They're watching closely, looking for changes in the comet's spectral signatures. As the plasma gets shocked by the CME, they might see hydrogen and oxygen lines shift, indicating speeds of up to 50 kilometers per second. The shape of the tail itself could change faster than the runtime of a movie, with bright filaments breaking free or a brand new tail forming in the wake of the disconnection. This is science happening at real speed, and it's a rare chance to see magnetic reconnection play out on a scale no lab on Earth could ever replicate. Every twist, every break, is written across the sky for us to see. And here's the most exciting part. The best data might not come from a giant observatory. It could come from you. Citizen scientists, amateur astronomers, anyone with a camera and a clear view of the sky, are now on the front lines of this cosmic event. Your photos could capture the crucial moments of this interaction. However, a bit of caution is needed. Experts are urging vigilance, not certainty. We're still not 100% sure if the CME will make a direct hit. Not every little ripple or flicker in the comet's tail is proof of the storm's impact. The key is to document everything you see, compare your observations with others, and help build a global record of how this incredible story unfolds. The only guarantee right now is change. The comet is in the path of the storm, and something is bound to happen. The next few hours and days are a critical window. The next amazing image, the one that shows the tail kinking or breaking, could appear in a single photo frame. And the whole world is watching together. So keep your eyes on the sky. The tools are ready. The data streams are open, and now all we can do is watch the comet corridor. We are about to witness a powerful, beautiful, and fleeting cosmic event. Let's see what the sun has in store for Comet Swan. Mark your calendars for October 21st, 2025. On that day, our solar system hosts a cosmic ballet of almost impossible odds. Comet Swan, a visitor from the icy depths of our own system, will make its closest approach to Earth, passing just 39 million kilometers away. For a comet, that's practically a cosmic drive-by. But this isn't just about one object. What makes this event truly extraordinary is the perfect alignment of celestial bodies, creating a scientific and observational opportunity that we may not see again for generations. Let's break down the numbers, because they tell a story that's almost too perfect to be true. Swan will pass just a quarter of an astronomical unit from us, that is 1/4 the distance between the Earth and the Sun. Put that in perspective, it's about 100 times farther than the Moon. But for an object traveling at incredible speeds through the vastness of space, this is an exceptionally close encounter. This approach isn't random. The geometry lines up beautifully. Swan's orbit crosses the ecliptic, the invisible plane where all the planets travel, at a very shallow angle. It's like it's merging onto the solar system's main highway. Its position just south of this plane places it directly in a zone of intense activity. This is where the solar wind, the stream of charged particles flowing from the sun, and the heliospheric current sheet, a massive rippling structure stretching across the solar system, are at their most powerful. It's like sailing into the heart of a cosmic storm. Now, here's where it gets even more fascinating. On that very same day, another object takes center stage. Interstellar Visitor 3, also known as I-Atlas. This isn't one of our own. It's a traveler from another star system, passing through our cosmic neighborhood. As Swan sweeps past Earth, I-Atlas will reach what's called superior conjunction, meaning it will be on the exact opposite side of the Sun from our perspective. Think about that. Two incredible objects, one born in our solar system and one an alien immigrant, will be sharing the same broad celestial corridor at the same time. They'll be separated by millions of kilometers, of course, but their alignment offers a rare, side-by-side chance to compare how a native comet and an interstellar object behave under the Sun's influence. For scientists who study orbits, this is a statistical jackpot. The odds of two such bodies, one from a distant solar orbit and one from interstellar space, converging near the ecliptic within days of each other are vanishingly small. It's a cosmic coincidence of the highest order. And the timing? It's simply perfect for anyone with a telescope or even just a pair of binoculars. October 21st brings a new moon. This is a huge deal for skywatchers because with the moon out of the picture, there's no lunar glare to wash out the faint light from distant objects. We'll have the darkest possible skies of the month, precisely when Comet Swan is at its closest and brightest. This proximity gives us another cool trick to play, the parallax effect. Because Swan is so close, its apparent position in the sky will shift slightly when viewed from different locations on Earth. It's the same effect you see when you hold your thumb out and close one eye, then the other. Your thumb seems to jump against the background. For Swan, this effect will be subtle, but measurable even with modest backyard telescopes. It's a tangible way to feel the three-dimensional depth of space. Looking at the star charts, Swan's path is a gift to observers. It will be climbing higher in the sky each night, its magnificent tail tracing a path across the southern constellations. If you were to map the gap between Earth and the comet in real time, you'd see it shrink to just a quarter of the Sun-Earth distance, giving us the absolute best window for observation before Swan heads back out into the lonely darkness of deep space. So, if you're hoping to catch a glimpse of this celestial visitor, timing and preparation are everything. The headline date is October 21st, 2025. That's the day of the closest approach, the new moon, and the darkest skies. But the viewing window is actually much wider. Let's get into the specifics of how and where to look. Swan's path runs just south of the ecliptic plane, which means it will be a prime target for observers in the southern hemisphere. From cities like Buenos Aires, Cape Town, or Perth, the comet will rise early and linger in the pre-dawn hours, its tail dramatically sweeping west across the horizon. For those of us in the northern latitudes, don't worry, you're not left out. The view gets better and better as October unfolds. In the early part of the month, it might be a challenge. But as we approach the 21st, Swan will start peaking above the southern horizon after midnight, gaining a little more altitude each night. To find it, you'll want to locate the constellations Grus, the Crane, and Pegasus Austrinus, the southern fish. Star charts place Swan right near their border. The easiest way to get your bearings is to find Fomalhaut, a distinctly bright star in that region of the sky. Just trace a line from Fomalhaut, and you should be in the right neighborhood. The comet's tail is expected to be quite long, perhaps 2.5 degrees across the sky. To give you a sense of scale, that's about 5 times the width of the full moon. This makes it easy to measure its length against the background stars. For binocular users, a standard pair of 7x50s will likely be able to capture the entire tail within a single field of view. It will be a breathtaking sight. If you have a small telescope, you'll be able to resolve even more detail in the comet's head, or coma, and see the structure within its tail. But you don't need expensive equipment. Even a standard DSLR camera on a tripod can capture Swan's ghostly streak with an exposure of just a few seconds. Now let's go back to that parallax effect. As Swan closes in, this is where a bit of citizen science comes into play. Because the comet is only a quarter of an astronomical unit away, its apparent position against the distant stars will shift measurably depending on your location on Earth. An observer in North America will see it in a slightly different spot than an observer in Europe at the exact same time. With a few hours of patience and a careful eye, you can actually detect this shift yourself. Amateur astronomy groups around the world are already coordinating for this event. They're creating imaging teams across continents, logging precise rise and set times, and sharing their images to create overlays that track the tail's changes from one night to the next. This global collaboration is turning thousands of individual observations into a single, comprehensive dataset. You can be a part of this. The checklist is simple. First, get outside and find the comet. Note its position relative to nearby stars. Then try to sketch or photograph its tail. Look for any interesting features. Are there any kinks, bright knots, or disconnected sections? Did the comet suddenly brighten or fade overnight? Every single observation, whether it's from a dark rural sky or a light-polluted city balcony, adds another pixel to this global picture. This is your moment to join the watch. This rare timing isn't just for stargazers. It's a documented scientific encounter. As Swan makes its closest approach on October 21st, scientists will be watching very closely for potential interactions between the sun's activity and the comet itself. Specifically, they'll be looking for any effects a coronal mass ejection, or CME, massive eruption of solar material, might have on the comet's delicate ion tail. We know that these interactions can cause rapid, dramatic, and visible changes. Sometimes a comet's tail can be completely ripped off by a solar storm, only to regrow over the next few days. It's a spectacular display of cosmic forces at work. However, it's important to be clear. While the potential for this interaction is high due to the comet's position, the exact outcome remains unproven. There is no established direct link between any specific solar flare and a comet-esque behavior before it happens. What is verified, however, is that this October gives both amateur and professional observers a unique, front-row seat to witness cometary and solar dynamics happening in real time. The global observation campaign is already underway, documenting every step of Swan's journey. This comet is giving us a precious opportunity to track the invisible forces that shape our solar system. Key results and discoveries are still unfolding, and many of them will be made not just by professionals in large observatories, but by people just like you in backyards all over the world. So get your gear ready. Download a star chart app, clean the lenses on your binoculars, and set an alarm for late October. This isn't just another comet. This is a perfectly timed cosmic alignment, a statistical improbability, and a chance for all of us to look up and participate in a moment of shared discovery. Don't miss it. Thanks for watching. If you're excited about Comet Swan, be sure to hit that like button and subscribe for more updates as we get closer to the big event. Clear skies,